Hey everybody, believe it or not, we're ready to start chapter 12. So this chapter is going to be a pretty short one. We're going to just highlight the main points of relations and functions. So I do want you to read over this first lesson pretty carefully. I want you to take some notes. I want you to know, first of all, that a relation is a set of ordered pairs. Okay, so like X, Y, and here we have a little table. Okay, 0, 1, 1, 2, 2, 3. This would be a relation. It's a set of ordered pairs. When we talk about the domain, we're talking about the x's, the things you put into the function. The range, the things that come out, okay, or the relation. And then, of course, x and y, input, output. I think you all remember my little function box from the past, right? So we're going to put our x in, do whatever the function says to do, multiply by 2 or add 7 or whatever it says to do, and the output comes out. So that, of course, works with relations, but also functions. Functions are specialized, okay? A relation where every x is matched with only one y, okay? And so those of you who had me last year, remember we kind of did a parallel. We said you can think of the x's as people and the y's as heights, okay? Tommy can't be 3 feet and 4 feet. He can only be one of those. Now, Tommy and Johnny can be 4 feet, right? But not Tommy being 2 different heights. So that kind of helps, that little parallel. So looking over here, we have our relation. We also can consider this a function because every x is matched up with its own y. Now, if I do another point here and I have 3 matched up with 3 and 2 matched up, is that one still a function? Yes. If I thought of this as Susie and this is Sally, they can both be the same height. So yeah, it's a function there. However, if I said this, that is still a relation, but it is not a function because I can't let the same person be 2 different heights. Okay? So take some time, make sure that you understand this, read through it, and let's right now look at the examples from the book. So on page 537, example 1, we have A, B, and C. A is matched up with 4, 0, and 0. Okay, this is our domain, our x's, our range, our y's, or our input and output. Okay, so is this relation, is it a function? Yes. Somebody can be 0 and another person can be 0. That's fine. So yes, that first one is okay. But the pizza one, look over at the cheese pizza. The domain, okay, so cheese pizza is $9.75, but then it's also connected to $7.25. Okay, the same size pizza cannot be 2 different prices. So right away you can conclude that relation is not a function. All right? All right, so then example 2, we have H is 4, 0, 6, 0, and 2, 0. So is this a function? Yes. 4 can be 0, 6, that's all right. So yes, it is. Everything's kosher there. They also want us, when it's a function, to list the domain. So the domain would be 4, 6, and 2, all of the x values. The range in this case is only 0. Okay? Now looking at J, okay, is this a function? No, we can't let Tommy be 5 and 7. So no, not a function. All right, then try this is next page, so go ahead and do that. You're going to find the domain and range of each relation and then determine if it is a function. so the first one, try this A. Tom is 18, Sue is 12, Sue is 28. So no, can't have two heights, not a function. It's a relation though, and the domain would be T and S, Tom and Sue. The range, 18, 12, and 28. All right, the next one, 3 is matched up with 36, 7 is matched with 35, and 6 is matched with 36. So yes, it's fine, it's a function. The domain would be 3, 7, and 6. The range, 36 and 35. Okay? Now, the next part of the lesson is to find the value of a function. So we're actually going to kind of use the function box, right? So when they label functions, they'll often say f of x equals, let's see, how about 3x minus 1? Okay, so this is like saying y equals 3x minus 1. So what you do is if it says find f of 0, find f of 1, you're going to plug in 0 wherever you see an x. Okay, so 3 times 0 is 0. So f of 0 is negative 1. F of 1, everywhere I see an x, I'm going to plug in 1. So 3 times 1 is 3, minus 1 is 2. If I wanted to do f of negative 2, where I see an x, I'll plug in negative 2. So 3 times negative 2 would be negative 6. Take away 1 would be negative 7. Okay? And then, of course, you can look at example 3 in the book. You are given f of t. That's how you say it, f of t. Okay? H of x, something like that. And they want you to find f of negative 2, f of 0, and f of 3. So you plug in to the function those values and get your answer. So I want you to look at example 3. Then I'd like you to do the last try, this C through F. Stop the tape. I'll put them up here on the board, and then you all can come back, check them, and then get started on the first lesson of chapter 12. First function, f of x, is x plus 3. So where you see an x, you'll plug in 5, and negative 8, and negative 2. So when I plug in 5, 5 plus 3 is 8. Negative 8 plus 3 is negative 5. And negative 2 plus 3 is 1. All right, so you're just plugging in the value into the given function. All right, now g, we have 3x minus x squared. All right, so when we plug in 0, 3 times 0 is 0, minus 0 getting squared is 0. So 0 minus 0 is 0. That one's the easy one. Generally, it's very easy. All right, now, negative 2. So I'm going to plug in where I see an x, negative 2. Notice it's minus, and I'm plugging in a negative 2. All right, so 3 times negative 2 is negative 6. Minus, now don't try to add the opposite here. You have to do the exponent first. So you're subtracting a 4. Negative 2 getting squared is positive 4. Now, you're going to be adding the opposite. So g of negative 2 is negative 10. Hope you see all that. If you need to go back through, you're plugging in -2 for x. It's minus -2 is getting squared. So -6 minus a 4, adding the opposite, -10. Then for g of 1, I'm going to plug in 1. So 3 times 1 is 1. Minus 1 squared is 1. So g of 1 is 2. Pretty simple there. All right, let's do this one. We have f of y is 8y squared plus 3. So for -1, I'm going to plug in -1 for y squared. So 8 times 1, right? Because -1 getting squared is 1 plus 3 should be 11. Okay, 8 times 2 getting squared, well, that's going to be 4. 4 times 8 is 32 plus 3, so 35. Now this one's kind of tricky, but you guys can do it. You're plugging in 1/2, it's getting squared, and you're going to add 3. Okay, you have to do the exponents first, according to PEMDAS. So 1/2 getting squared is 1/4. So 8 times 1/4, think about that. 4 into 8 is 2, right? 8 times 1/4 is 2 plus the 3, and you get 5. Okay, 1/2 got squared times 8 plus 3. All right, and the last one. Okay, your 0 is really easy. That would cancel out. This would cancel. 0 plus 0 minus 1. All right. Now this one, I'm going to be very careful. I'm going to say 2, x is getting squared, plus x minus 1. That's what the function is. Wherever there's an x, I'm plugging in -2. According to PEMDAS, do my exponent first. So this is 4. 2 times 4 is 8, plus a -2 minus 1. Okay, so 8 plus a -2 is 6, minus 1, 5. And the last one there, let me move this out of the way. Give me some room. We're going to plug in 3. So 2 times x getting squared plus x minus 1. Taking the function, wherever there's an x, plugging in. Don't shortchange yourself. Show your work. Show your steps. Okay, this is going to be 9. So 2 times 9 plus 3 minus 1. 2 times 9 is 18 plus 3, 21 minus 1, 20. Okie doke, we have completed 12.1. Refer to NREV, see what your assignment is, get started, and best wishes. Love you guys, miss you.